Flipping over to the last example on page 3, and this is the kind of problem you might see in a chemistry class. We're given that Joel has 2 bottles of acetic acid, an 8% bottle, another bottle that's stronger at 12%, and he wants to combine some of each, so that he ends up with a 300 milliliter bottle that's 9%. So just like a lot of previous examples, we're going to let decide on our variables. I'm going to let E represent the amount of 8% solution. So E is some number of milliliters of 8% solution. And T is going to represent the amount of 12% solution. Now, he wants to end up with 300 milliliters total at the end of this. So that would mean that E plus T has to add to 300. The amount of 8% solution plus the amount of 12% solution has to add to 300. So for example, this could be 100 and this could be 200 adding to 300. Okay, so they have to be 2 numbers that add to 300. Now, I'm going to use the method of substitution here. So I'm going to solve this one for E. We'll get to our second equation in a moment. E plus T equals 300. So if I rearrange, subtract T from both sides, E would be 300 minus T. Now the second equation involves the percentages 8, 12, and 9. And so this represents 0.08 is 8% of the 8% solution. 8% of the E amount is the amount of acetic acid from that solution. Plus 12% of the 12% solution, that's the amount of acetic acid from the 12% solution, and that must add up to, he wants to end up with 9% of the 300 milliliter solution. So that must add up to, that's the actual amount of acetic acid from the, to end up with. And so let's simplify this. 0.09 times 300 is 27. So that's all I've done from this line to this line. That is 27 milliliters. So that's actually the exact amount of acetic acid in the 300 milliliter solution. Now, again, I said I was going to use substitution. So here's the substitution I'm going to make. I'm going to substitute what E equals in place of E in this second equation. And so I'm going to rewrite this equation with 300 minus T, substitute in place of E. And now again I have just T here, so I can solve for T. I'm going to expand in the 0.08 here. 0.08 times 300 is 24. 0.08 times negative T is negative 0.08 T, and then plus the 0.12 T equals 27. So collecting like terms, negative 0.08 T and 0.12 T add to 0.04 T, and then subtracting 24 from both sides, or 27 minus 24 is 3. To solve for T, we would divide out the 0.04. So T is 3 divided by 0.04, which works out to 75. So that would mean that we need, or Joel needs, 75 milliliters of the 12% solution. Now we need to find the amount of 8% solution. So going back to this equation, or this one, we're going to substitute again the 75 in place of T. That's what I've done here. 300 minus the 75 is 225 milliliters. So it looks like he needs 75 milliliters of the 12% and 225 milliliters of the 8% solution. So to check, he's supposed to end up with 300 milliliters of this acetic acid solution. So the E plus T should add to 300. So 225 and 75 of course do add to 300. So that part checks. Now the second part is the amount of acid he ends up with. And so going back to this equation here, 0.08 E plus 0.12 T. So again, putting 225 in place of E and 75 in place of T. Again, this should work out to 27 milliliters. Again, 0.09 times 300. So if we multiply this, you get 18, and 0.12 times 75 is 9, and that does add up to 27. So it does check in the second equation. The amount of acid is correct in that 300 milliliter solution. So just as a concluding statement, Now that we know that our solution is correct, Joel should use 225 milliliters of the 8% solution and 75 milliliters of the 12% solution. And that's the end of the lesson.